Can see your beard, Cobus.
Oh, I don't know if that's good or bad. There we go. Light is on.
It is on.
And also,
Hello, hello, hello.
I need to sit like this today to hide the mess that's behind me.
We
I'm
can't see the
busy.
mess. We can't see the mess so far. Uh,
I'm
but
busy sorting all of my tools and computer parts and all of those things bit by bit.
I
It's
actually
very
have a
messy.
I have a box of computer parts next to me. I've got over the last week, and I'm still trying to figure out what I'm gonna do with it. So,
Oh
um,
yeah.
but yes. Hello, everybody, and welcome to another edition of DevBeardOps with not Cobus and not Darko. You get to guess which one is which. This is a weekly show we do on Twitch here at AWS and our own respective Twitch/YouTube channels, where we talk about technology, the cloud, AWS, baldness, and yeah, it's called Dead Beard Ops because, well, I guess you can see, but the most important thing is it's the beard on the inside that counts. So if you
Mm.
cannot grow a beard on the outside, I'm sure you can grow a beard on the inside. So today is, well, first of all, how are you doing, Cobus? Are you good?
Me, I'm
All good?
I'm doing well. I'm actually very energized today, as they say, because we've got our first like rainstorm for the year. Like we've had a bit of rain,
Ooh,
obviously this year so far, but it's summer this side in Cape Town. And we've got a first like storm where it's like
yeah.
storm warnings and wind and flooding warnings and all that. So it's been raining since last night, and
Wow.
I love the rain. So it's like this is quite nice sitting inside listening to the rain.
Well, slowly it's coming to winter now, or actually fall in South Africa, right? So,
No, you're not doing it right, Darko. It's coming to winter.
oh, winter, okay. Winter in
Yes.
South Africa. Yeah, okay. Yeah, the winter is slowly ending in Germany here, so it has been -6 last night in Berlin. But it's better now. So it's we
Mm,
have sunshine. It's we started to get flowers outside, so hopefully sometimes it's
mm.
gonna be better. Cool. Well, happy to hear
Yeah.
that you're energized. I also feel the same thing about rain. I love the rain, and
Mm.
it makes a day better. I know, hate me.
And
Okay,
also, just my weekly disclaimer, this isn't Guinness. This is just caffeine and sugar-free tab. I wish it was Guinness, but it's a little bit early for that, given that it's a work day.
sugar-free tab is a drink they have in South Africa. Just an FYI,
Yes.
it's a cola right drink. Because yeah, it used to be American, I believe. Tab Cola was like an American thing,
Mm.
and it's not sold in the US anymore, I believe. So it's only
Well, it's
South
not going to be
Africa.
sold here either soon. Coca-Cola actually announced like scrapping, I think, half of the brands that are not that popular, and Tab
Wow.
is one of them, unfortunately.
Well,
Yeah.
there you go. First
Mm.
question to the audience, everybody out there, is the are the audio levels between us
Can
good?
you hear us?
Can you hear us? I'm sure you
Hee
can, but
hee.
are they just leveled?
Mm.
Because I can hear
Yeah.
Cobus fine, although he does sound a bit quiet to me. Just want to make sure
Oh,
that we are equally loud. But that just might be me, Cobus. So it's really not
I
not
just need to.
not indicative.
No, I just need to check because I did have my 3-year-old doing things on my desk. So
Okay.
if there's a knob, she tends to turn things and press buttons, and yeah, that's why I
Okay.
no longer have that live tweet button.
Ah, the live tweet button. Okay. Yeah, be careful about those and little kids.
Oh yeah, definitely. Cool.
Okay, so
So, Darko,
go
what are
ahead.
we talking about?
What are we talking about? Well, actually, last time where last we left off was at Cliffhanger, where we talked
Dun
about
dun dun.
software testing. We spent the last week's stream about discussing on how do you do software testing. I'm lower. Okay, give me a second, Mr. MD Lawrence. I want to make sure we're all equally as loud.
Mm.
But wait. No. It's the StreamYard thing. Audio mic volume. I think is this better now? Darko is soft. Yes, I get told that a
He
lot.
is a
Oh.
softie. He gives great hugs.
So yeah, I will try to increase my audio level because what is it? This tool we're using, StreamYard, is
Mm.
has its own audio management. So
Mm.
also I can go here and my volume mixer. Oh, Windows, where art thou? Open sound settings, sounds,
So many buttons.
input. No, not that. input, input. Okay. Okay,
Cool.
so good. Thank you very much.
Okay, awesome.
So last we left off, we talked about software testing. We talked about
Yes.
where do you catch errors when you deploy code. Where is it the cheapest to catch errors inside of your lovely text editor or your IDE up to, well, your unit testing. I would think the last thing we talked about was unit testing, and before that we talked about your code reviews.
Yeah.
So today we're going to be taking it a step further. We're going to talk about something called integration testing and some end-to-end testing, and finally testing in production. So that's kind of the topic of today. And everybody on stream, feel free to chip in, feel free to add your comments, add your ideas. This is not a one-way discussion. We like to discuss this with you. So if you have questions regarding this, if you have your comments, and we had a lot of great people pitch in last time. So thank you very much, and please continue to do so. So Kobus, integration testing. What is it? When I tell you, well, actually, no. Let's step back. Unit testing. How do you see unit testing? Explain to me unit testing.
Okay, so you are testing a unit of code or functionality inside your application. So let's say, take that example of what I've been working on is a thing that processes data from sources and then stores it. So one of the sources in my case is YouTube data. So what I've got tests for is that given this following input. So the way I structure my code is that there's something that reads a file or calls an API to get the data. Okay. Or calls a database. And then once it's got the data, it sends the data into a function or method. And then that method takes the information and does something for it and turns it into a list of other objects or aggregates the data or something and then spits it back out. Now, what a unit test will be is that I write a piece of code that says, here's the input and this is the expected output. So if I give you a list of 3 YouTube videos, each with 10 views and 10 minutes watched, if this function aggregates, I expect the output to say 3 videos in total 30 minutes, if that's what the function does. Yeah. So what you do is you write that little test, then you go create the method, you figure out the logic, you write it, and then you run this unit test against that method. And then what it does is it actually obviously validates, does that piece of code that you just wrote do what it's supposed to be doing based on the input and output that you control inside your unit test. And then it becomes a little bit more fun as well, is that you also in your unit test want to test for things scenarios that you may encounter in future. For example, what happens if I send in an empty list? Or what happens if I send in a list where some of the fields are missing, to make sure that the app actually can handle those based on the different scenarios that you're dealing with. So just test a small unit of code inside your bigger application.
I think that's the big thing. When I first met a unit test, for me, what a unit test is like, it's just going to do all. I just give it my code and it does something. I want to make sure that my code works, and my unit test will check if my code works. That's not the thing. Unit tests check specific things, as Kobus says. So a specific unit of code, of work, it only tests that. However, there's also a couple of more rules when it comes to unit testing that I've read upon, is what makes a unit test compared to something else. So what I read, and you can argue with me on this one, is a unit test should never touch a database. A unit test should never reach out to the internet. Unit test should not even write to a file system. So unit test just does a specific small thing. So if you have a unit test if you have a test that needs to pull something from an external API, mock it. Create a JSON object locally that's going to read from it and just act like, this is the data I received. Let me see if I'm doing something. That is very important. Because if you start introducing dependencies into unit tests, gee golly, that's going to take a lot of time.
Well, not only does it take a lot of time, it also causes problems for you, because what happens when the API that you're calling is down, or the data in the database isn't the same data, or the text file is missing? And then even fun over time is you start hitting like API limits. If you've got lots of tests running the whole time, the API might change, and then all of a sudden you cannot validate that your code does what it's supposed to, instead of just validating that small get the data from the API section. So no, those are very, very valid points.
Yeah, so because you want to make sure that your code is working, not everything else. you get to that everything else part later down in the line, because if your function, if you have a little method in your object that does something, and you want to test if that is working, then you just test that, not everything else around it. You will give it mock data. You will give it something that's gonna emulate an actual thing happening, and it's gonna output is it true or not. So, and this is a great example with your thing. So Cobus's application processes some data from YouTube. Instead of Cobus's unit test going out to YouTube and getting that data, Cobus just has a JSON file locally or a CSV file with information, with mock information that tests against that. So.
Yeah, I mean, like an example here is that I've got a YAML config file for the actual application that I'm going to be, obviously, I want to test all the different configuration scenarios. I don't have 50 config files. I've got strings inside my unit test saying, here is the entire YAML blob for these tests, and then change them as I need to.
Exactly. So those are unit tests, right? And discussions between, okay, so what is a unit test and what is an integration test? They can look very similar. So when it comes to the actual code behind it, and if, for example, if you're using Python, your Python PyTest can do both unit tests and integration tests. Doesn't matter. It's just the way you test things that are different when you do integration testing. And the name integration there has a reason, because you're integrating all of your different units to perform a piece of work or to perform a thing, and you're testing that. Now, this is where actually, and again, according to my reading, it's not the developer who runs the unit tests. It's the testing team that runs the unit tests.
No, Docker, this isn't the 90s. Slow down.
Okay.
No, so if you, I'd be scared if you tell me there's a developer that has access to tests that is not running them, because that means that the developer is not building tests to make sure that the code is working. Just quickly for those in the chat, those of you that are doing active development at the moment or involved with software development, tell us how many of you actually play with the tests, run the tests, add to the tests, or modify them. We want to get a sense of like who else is involved in it, because like I said, if you're writing code, you need to write tests to make sure that your code is actually working the way you're supposed to. Otherwise, it's just like, hope-driven development where, I hope this works, I hope this doesn't break. And if you want to be really uncomfortable, go to the owner of the company and say, listen, we're going to be releasing code this Friday, and we hope it works. We haven't tested it, we just hope it works, and see the reaction, and then use that as a barometer to figure out, are you doing the right thing or not? Let me know how it goes. I'd love to hear.
Yeah, because like you should be doing the writing, test writing. There is a testing team, of course, but that's something else. That is somewhere beyond. But you should be the one as a developer who writes those tests, if you are a developer, right? So Learning T says, I do it as a part of deployment jobs. It tests all unit test cases. Okay, excellent. So your pipelines, your deployment jobs should run your tests. Now, the difference here is, what are you testing in which phase?
Yeah.
If you look at the standard CI/CD pipeline, you have your source phase, your build phase, your test phase, and your deploy phase. Usually, the unit tests are part of the build phase. When your code is being built, this is where you run your unit test, just to make sure that each of those units is doing what it should be once it has been built, or if there is a build at all. So, but then the actual integration test, the thing we're kind of trying to slowly ink to, comes at the second phase, the test phase. This is where an automated solution. Now, there's a lot of them. I mean, I have not had a lot of experience with the big ones like Selenium and whatnot, but this is where a solution actually runs those integration tests. So, Cobus, what are integration tests?
So, integration tests to me are where you actually test, are all of the components of your systems working together to solve a specific thing. So, for example, you would spin up let's say you're doing microservice architecture. You've got 5 different services that are running, and when you, for example, create a user or update a piece of data, it goes through more than one of these systems. So what integration testing would be is to have a framework that can spin up the system, and actually then run a test saying, listen, when I invoke the create user, if it's an API call or however you do it, does it pass through the different systems, and then check that it creates the user in the end. So have some kind of database or mocked out database. There are ways to mock that out in memory as well. And does it end up creating that user, and did all of the code parts execute and do what they were supposed to be doing? So it's more like almost black box testing, where there's this box. You don't necessarily care what's going on in the middle, but when I feed it this, it needs to output that.
Yeah.
So you've got that type scenarios. We make sure that everything is working in correctly. And also where this becomes important is like with systems, for example, that you do inversion of code. What's it? IOC. Inversion of concerns, where you do, for example, if you use like injecting different classes and wiring them up at runtime, not at necessarily development time. So you've got interfaces in different versions of the code, well, not versions of the code, different implementations of the code depending on the scenario. You can start testing those kind of things, which are only doable at runtime. Because in a unit test, you can say, well, I'm testing this specific class, but I've got 2 or 3 different ones depending on what we're doing. So that's where the integration tests become important.
Yeah. And to that example, like when you create a user, usually it's not a single action. Usually it's not a single function, or it shouldn't be a single function. It shouldn't even be a single API call. You might have an API call that says, create me this user, but that API call is going to invoke a whole bunch of other things to do that. And an integration test is actually running those things, integrated sets of different units that achieve a certain outcome. And this is where your unit tests go ahead and reach out to external things. They can also have mocked up things. You can have mock-ups. Just people place mock-ups actually in integration tests, because if an external dependency fails, they want to be able to test it even then. But you have to be careful. If an external dependency fails, your test doesn't catch that, or you should be able to catch that an external dependency has failed before. And I think integration tests are very critical, because they literally tell you, will this work? And they are the thing. Okay.
They tell you, will it work to a certain point, because remember, there's only one production.
Exactly. They will tell you if it will work. Almost. There is, and that's a very good quote. There is only one production. Yes. I need to print that out. There is only one production.
Yes.
Because your biggest test is in production. Believe it or not, that is the test.
The best quote I ever heard was something along the lines of, every single company out there has got testers to test their product. Some companies are just fortunate that it isn't their users.
Yes. Oh boy.
Yeah.
The worst way you can test something is, well, actually confirm if something is working, is by getting a customer ticket. So if you
no Twitter storm.
Twitter. Well, okay, yeah, let's move to Twitter. So if Twitter is your integration test, that may be a problem. And don't get me wrong, your code is gonna fail in production. Be sure of it. Bigger companies have code problems in production, and that will just always happen, no matter how good you build your unit test. And Amazon, actually, let me find this article. It's on the builders library. There's a great article by Claire on how our pipelines work, how AWS's pipelines work. It's just amazing. We have this big old set of integration tests. So let me actually just give me a second while I search for that.
It's a great point, because what that article, I believe, digs into, I've read a bit of it. I haven't had time to read it fully in one sitting. Is deployment's interesting, because usually when we think about deployment, it's let's kick off a single deployment, it runs to completion, and then we're done, and we can now deploy the next one, and it runs to completion and it's done. But when you sorry, this is quite fun. There's a comment here about ProtoDuff that says, I think I'm drunk, I'm seeing double. Yes. But when you start doing large-scale systems, especially where you've got multiple different teams working on the code base, deployments can start being triggered very close together. And then things become super interesting, because what happens is that 2 deployments are now queued. Do you deploy the first one to completion and then only deploy the second one? Or do you say, let's roll up to the second one, we know that we've got these 2 units, and then when something goes wrong, well, how do we figure out which one was the one that introduced the change? And then if we need to roll back, can we roll back? How do we roll back? All of those things.
Yep, yeah. Rollback strategies are, I think, a completely different topic. Rollback strategies are just, there's different ways to do that. We'll mention some of them when it comes to the testing and production. But this document, actually, let me paste the link in the chats here, just so you can have a look. By the way, the Amazon Builders Library is just excellent.
Yes.
Very technical library of documents on how Amazon does things. Great. So this document has been written by Claire. And it's about how we do CI/CD at Amazon now. So it describes all the different phases. And by the way, these links will be available later on in the description if you missed out on them. But basically, they explain how do we work with source and build. This is where our unit tests are living. For example, in the build phase, this is where the unit tests are. This is where your static analysis, your coverage checks, all of your things that are part of that are. But then once you move to this integration part, the test part, this is where a lot of different things happen. This is where your actual integration tests is. But this is also where the load tests exist, and metrics monitoring. That's a very interesting point. Metrics are not your standard test per se. It's not like, oh, well, does my code work or not? Your code may work, but what if all of a sudden your code impacts your metrics by a lot?
Make things slower.
Yeah, it increases the... So let's say you have let's go back to that user API thing. You have an API that creates a user, and you make changes to it. Unit tests go fine, it does what it should. You go to integration tests, it does it fine, perfect. It creates users, it's all great. But it takes 3 times as long because now you made a change. So metrics, in this case, metric monitoring is very important. So you will see this outline is like, okay, why does my user creation take 7 minutes now instead of 5 seconds? That's also very important.
Yeah, and also the thing here to understand is that, remember, software is complex systems dealing with different components. So let's say the database is a classic example where you have unintended side effects. So just by changing the way, let's say I'm creating user and I'm inserting them into a table, but I introduce some new logic where I could do an interesting heavy query on multiple other tables, including the transaction table, to check, have we seen a user with similar names just before now as a random example?
Yeah.
That causes load on that table. And depending on how you structure your query, you can potentially create locks on the table affecting other systems, even though your piece of code doesn't touch that other area of code. And that'll only be picked up in this area, because now what happens is all of a sudden you're now running your new code along with all the other code that keeps hitting the database as well. And now we start seeing, well, you introduced new user logic, but all transactions are slow. So this is where it becomes important.
Yeah. And in our example, so in our testing phase, we have different stages of that testing. We have alpha, beta, and gamma, and also gamma 1 box, but they're all different likenesses of production. So alpha is the least like production, beta is a bit more, gamma is as most production can be, but also there's a different gamma version, the 1 box version, where it's running on a single thing instead of a multiple cluster of servers. So this is where you actually get to test your load, as Koba said, right? Just to make sure that this thing doesn't break anything else. Because, if code can work without, you noticing that it will break things down the line. So.
Oh, yeah.
But yeah, a lot of things. So yeah, there's a bunch of things like backwards compatibility testing also, because you want to make sure that your code that you deploy does not break the compatibility of other things. Because one of the things that it's not just like, oh, it will break my other elements. No, because some systems might still want to talk to the old version of the API for a while until this one is done, unless You will not want to break an API or a service or something that can no longer talk to some other older ones. So that is pretty important to do those things as well.
But it's also like, if you scroll a little bit down to show that diagram over there, is that the way you should be rolling out your service is not to say, here's version 2, everything version down, version 2 comes up, because that is a service interruption, because all of a sudden, while version 2 is coming up, or if you've got version 2 already up and you just shift traffic across, if something does go wrong, it goes wrong for 100% of your users.
Correct.
And that's a problem, which means that what you want to do is you want to gradually, and this is where the term canaries, you might have heard, like canary testing or canary release, comes in. And it's from the canaries they used to use in the coal mines, which would warn people if there was a gas leak, because the canary would pass out first, and you'd immediately see, well, the canary's passing out, we're going to be passing out soon next, let's, get out of here. So what you do is you release the new version and you send a small portion of the traffic to it. And there are various strategies around how do I decide who are the people that are going to be testing this goes. But then you start looking at the metrics and everything for that second version as well. Look at error rates, response times, anything that makes sense to you. And then you gradually increase the number of people that use that over time until you reach 100%. And then you still wait a little bit just to make sure that this is actually working before you then deprecate the version 1 deployments.
Yeah, and as you can see here, in our gamma 1 box and the gamma stages, this is where we run our canary test constantly. This is where it's kind of, even on the test environment, you're running canary tests, because you want to be able to notice the things. And canary tests are just a test that keeps on increasing the amount of being deployed while it is listening for mistakes. You have a bunch of alarms, a bunch of metrics trying to monitor, just seeing if something happens. The same thing, like you look for your canary so it's still alive in its cage. So yeah, pretty important. So I would say that the testing phase, or the unit or the integration testing phase, as seen here, is the most complex one. This is where where you have dedicated testing teams for this.
Once again, potentially, depending on the size of the company, depending on how you're doing it. What you don't want is, I can tell you a very fun place I worked at. I won't obviously mention the place, but basically we had development teams, we had testing teams, and we had ops teams.
Okay.
And then also the PM, the product management teams, and each had different incentives. Project management was scored on how many features and were the features delivered on time.
Okay.
Not whether the features were working or not.
Okay.
First, it gets better. You're going to enjoy this one. Then we had the testing team. The testing team was incentivized by the number of bugs that they logged, which, just as a quick side note, I was working on reporting at the time, and I was a little bit inconsistent with the title of the reports. So I had 50 individual tickets logged with full stop missing at end of report title. Because guess what? That was 50 tickets for them. Instead of having one bug ticket saying, listen, here's a list of reports, the title doesn't have the full stop in, or it needs, or whatever, go fix all of these 50, and then once we're done, we continue with it. And then you had the ops team, which was measured on uptime and number of errors in production. And now you can see this whole recipe for disaster, because the PMs push to get things out regardless of whether they're working or not. The QA team is being fanatical about any small thing that they can nail you on, trying to get it there. They didn't have a penalty for production breaking, which is interesting. They only were incentivized for a number of bugs. And then ultimately the poor ops team were always like, we don't want to release anything because it's going to break the whole time. Yeah.
Well, that's
I think you're on mute. Yeah.
So I'm on mute. So that's also a thing when it comes to different types of metrics for your teams, and you have to be careful with that as well. So I'm just trying to put up something on here on screen so people who join the stream know. Give me a second. Entertain the folks while I type out something here on Streamyard. By the way, to answer the question from somebody later on, yes, we're using Streamyard. It's a wonderful tool.
Yeah. So what else have I seen that has where it has actually worked is when you get the more modern way of building software with the dev team, the testing team, and let's say you've still got a separate ops team, they actually sit together and work and start planning out how features get rolled out, where the checks need to be, how to make sure that the code is working, where everybody works together and everybody's aligned both on what they want to do and also how things are being measured.
Yeah.
Because if you say testing, developers, product managers, and all of that, here is your set of criteria that defines success. Releasing X number of features, that are working
Yeah.
with this number of bugs in production only. Then all of a sudden, and uptime. The developer is concerned about uptime. The developer is concerned about bug count. QA is concerned about uptime and all of that. So that means that everybody actually works together. So think about that in terms of when you start talking about this.
Yep. Exactly. So, if you're in management or if you're managing developers, give them incentives to write good code. Don't just have, hey, you can have a developer just bash out wrong code and it will be caught somewhere down the line. But that's not the goal. Even if you have proper testing strategies, make sure that they're incentivized by doing good code. Because I mentioned this last time, but it's not the same cost of a test in different stages. If we go back to that pipeline, your source phase, your text editor, your Git repo is the cheapest place to fail because you will not inconvenience anybody besides your text editor or maybe somebody looking at your code. When you move to unit tests, this is where you actually engage a system to do things. You spend CPU cycles, it costs a bunch. But if your test fails on integration, this is where you actually deploy that code and started interacting with different services. You can put a significant money value on that. And of course, the worst test to fail is in production. And, well, you don't want to hear your Twitter knocking on your door and saying, hey, Darko, your software sucks. It is pretty important to kind of try to get the things correct in the correct places.
And I mean, this feedback loop is interesting. There's another aspect to this, which is not just the time in terms of it takes to actually get the code or to pick up the bug. It's also to fix the bug, because
absolutely.
Here's the thing with software developers. We finish the code and then we move on to the next task.
Yep.
If you bring me a bug back 5 seconds after I wrote the code, it's all going to be still in brain. It's literally like a computer where it's in memory, and I know I've got the context and I know how to fix this. If you bring me this bug 3 weeks later, after I've done 5 other things, I'm going to have to go like, let me go look at the code again. Let me see if I can figure it out. What was I thinking about this? I didn't document it properly. It'll take you longer to fix as well. And the worst part then is that that's a bad cycle, because now all of a sudden, whatever you were working on is interrupted. You're switching context to fix that old bug. Then you come back to this, what you were working on, switch back context. It slows down this talk, and you get into this whole cycle of constant interruptions. And you go into firefighting mode where it's like the code quality just decreases.
Exactly. So that's a very excellent point. The faster you get the problem noticed, the faster it will take the developer to fix it. Not just, not the mean time to resolve, but literally how much time will it take the developer to figure out, oh, that's an error in my code. Because if you tell them, hey, this doesn't do it correctly, the developer may immediately, oh yeah, it's on line 45, I remember it. Let me do that. So it is a really good point on that. So good catch.
Oh yeah, no. And the comment down here from Canary, which is, or you forget entirely and ask who wrote this stuff. I have done this so many times where I went into the code base and I got upset, like, who the hell wrote this crap code? And then I look and I'm like, this guy.
Git log.
Yeah.
Is it called git blame?
Yeah, you can use git blame to actually to flag things. It's I've been there many times.
Yeah. But it's important in that sense. So you find those things out. So integration tests are important. Integration tests, your metric monitoring and all those things are important to have them in the right stage of your development cycle. So you may catch those errors, those problems at the correct thing. Because unit tests and integration are definitely not the same thing. They may look on the outset as the same thing. But as Robert said, an integration test is a black box test. It's a little thing that you don't see inside. You just give it something and you expect something back. While integration tests, you actually test those things inside. That's the transparent box, or however you would like to call it.
No. You're confusing the two, because the integration tests are the black box where you just put something in and you expect something out. Yeah, just to clarify. Yeah.
Okay. But now, talking about the other types of testing, so something that goes after you you finish your integration tests, after you finish your load testing, there's something called an end-to-end test.
Yes.
And I've heard this term a lot, right? Oh, we do end-to-end testing. How would you define end-to-end testing, Cobus?
I will get to that, but before that, we just quickly have to thank our sponsors. Sorry, I just realized we're in the middle of the thing. I'm just kidding. We don't have sponsors. I just want to... Sorry, in case you're wondering, I like putting pranks on Darko as well. I love humor, and I love making people uncomfortable. And if you rewind this or watch this again later, you will see how quickly you went like... Because this is not a paid show. No, I just want to quickly, because I saw now we've had a couple of people join, just quickly reiterate what we're doing. Is this is the second session that we've been talking about how to test software, where we test software, how to test software, and all of that. And also just quickly, you will see the links to the YouTube channels down below where the video will be posted. This one will go on the Not Quibus, Not Darko channel. Suggest if you want to see when they come out, go to subscribe there. Cool. Now that we've lost a lot of people because I was joking about sponsors.
You got me like, and I was in a moment like, who is our, what? Okay. So.
Yes, sorry, I couldn't resist doing that. Cool. Back to end-to-end testing. So how end-to-end testing would differ in terms of how I view them to integration testing is you are trying to test the system as in does all the different components work well together. Yep. End-to-end testing is literally like when I make the API call, I go and look at what happens in, let's say, for example, a database or where it goes on the other side, like literally go to test the full end-to-end run of calls through the system and also make sure that it hits persistence and external API calls, all of that, and actually does that. I'm actually not quite upset because I see we had about 9 people drop off the stream now with my joke about the sponsor. So apologies for that if you are watching this later.
Do you have problems with VPN?
No, we're not going to go there. But yeah, and end-to-testing does become a little bit more difficult because knowing what to expect in the database is, the statement is simple. I want to make sure that the data is there based on what I did. But it does assume you know what the current state of the database is before doing that test, and then also what the expected state after the test is. And with databases, that's something that's difficult because, especially if you're doing these end-to-end tests on, let's say, a live system, things are flowing past. You can't just say, I'm creating a call to say create a new user, and therefore I'm expecting the database table to have 5 users in it, where 5 people might have signed up again in the background already, and now you've got 10, and then it's the wrong value. So it becomes increasingly more difficult to write these tests with absolute inputs and output values that you're expecting.
Yeah. And also, end-to-end tests are sometimes involving these bots that will act as users. They will, if there's a thing to click on, they will click on it. So they will try to emulate a user doing something on your website, for example, to do it entire thing. So it is also part of the end-to-end testing. So good explanation on that. So once we're done with end-to-end testing, once we have all those things, you have your user acceptance testing. That's a separate type of test. It's not a very technical test. It's a, hey, I have a subgroup of users who want to beta test my thing, and then you basically provide them access to this, and that's my UAT in this thing. So so that's kind of one of the approaches of UAT, and UAT or user acceptance testing is anything. Like I've deployed networks, and we had UATs on a part of a network just to make sure that Wi-Fi is good enough and that people are satisfied with it. And it's more of a, it's not a very technical test because like you may get technical feedback from people, but it's more like I like it or I don't like it as much. This feature is not the thing I wanted. So take your UATs with a pinch of salt always. But yeah.
Fun user testing at the moment. I just realized this is not the right cap for this specific SodaStream bottle that I have at home. So it's like, yes, it can fit.
Did you steal a cap from somebody?
No. It says we've got 2 different sets of bottles, okay. I'm assuming. I'll need to go check because I know some of the caps I've seen are black, some of them are gray, and I've just never paid attention. But yeah,
there you
go. Fun little failure in production.
There's a question here from M4 Nishan. I hope I'm pronouncing that name correctly. Could you give us some insight into AWS Canary? If not now, in a separate video as well. Really interested in it. Don't know that it's been discussed in a previous video. What is AWS Canary?
I just Googled it.
Okay.
I just Googled it, and I was just curious because I thought it was a new service that I'd missed, and no, it's not. So It's called a Canary deployment,
Okay,
or
okay, that, so
having
that.
a Canary version out of your app, and it's more a concept, and there's
Yeah,
no specific way that you would implement it because there are various ways. It's that classic one with it depends. So what you would do is that a Canary deployment, as such, is where you take your code and you deploy it, and then what you do is you send some traffic to it, not all traffic, to test whether or not it's working. And then that allows you to make sure, A, does it function the way it's supposed to? Does it have any impact on the system as a whole? You might have also heard about dark launching features. It's a case where as you progress in terms of like getting more mature with your software process, you can actually release code behind feature flags. That means
yeah,
the code has been deployed, but the code is not being used yet. So there's literally a flag that says, unless this flag is said, don't use this new code path that we just added.
yeah,
And this actually happens quite often. And then what you can do is there are various ways you can say, let's start shifting some traffic over there. You can, for example, on your load balancer, say, send 5% of the traffic to this new version. And you can even add filters. So what you can say is send 5% of all traffic originating from, as an example, Germany to this new one, because this is a feature that we know might be applicable to German users. Or for people with specific characters in their names or specific length of names, or there's a whole bunch of features. Because remember, as you've got traffic coming in, you can see what the request is that you're dealing with, and then figure out how you want to filter and do those things. And the reason is that it prevents this whole big bang of, here's the version 2, it's broken, everybody, you're down.
yeah.
So yeah.
Exactly. So, I also thought like, oh, a service? Did we launch a service? I didn't know. And that happens, by the way. That happens. We get a service launched, and you tell us about it. So don't be concerned about that. But
Yeah.
those are Canary deployments, and feature flags are a very powerful thing because one great thing about feature flags is that you can have code deployed in production, but not be accessible. So feature flags are a thing that you can have basically a fully running version of your new code or a feature or something, but it being disabled. Then, as Kobe said, enable it for a subset of the user or for everybody by just toggling it on and off. So,
Yeah.
and if you wish to use AWS for that, AWS App Config is a great tool to give you feature flags. So, App Config gives you the ability to actually just, hey, here's a configuration you can request from an API, and it can be just a flag. So, that is a great way to approach that. So,
Yeah.
but yeah.
Cool.
So to slowly wrap up, I just want to mention one last type of testing, and this is the ultimate testing, the testing once your code is in production. That's actually a great connection to feature flags and to Canary deployments, because when you do things like Canary deployments, you are automatically applying some testing strategies to a production workload. Why? Because you are continuously monitoring how your code acts in production. And if something goes bad, you can roll back. Hopefully, if you have the right tooling and deployment procedures in place. So think of it as this. Cobus launches his application that does YouTube, and it's running on somewhere, whatever. And all the tests pass. Unit tests, integration tests, metric tests, perfect, excellent. But there's just something about, as Cobus says, there's only one production. Something about production that's different. Is it the user load? Is it the amount of data? Is it the lag between different elements of the cluster? For some reason, the code just doesn't work good. You notice it. Oh, there is a latency in my calls. There's all of a sudden a higher spike of utilization in my servers, or I get bad requests back. I get a lot of 5xx errors on my application logs. This is the ultimate testing. Or, hey, that's the better option, but if you get a tweet, that's worse. So you keep on monitoring for these errors. You keep on looking. You're constantly looking for this information coming out of production. And if you reach a threshold, you're like, okay, this is bad, roll it back. And no harm done. Well, no harm done.
I think we can probably dedicate the entire next episode on rollback is sometimes a myth.
Okay. So next episode, rollbacks. We're going to talk about actually the deployment strategies. Actually, that's a good point. Next episode on Wednesday, next Wednesday, this discussion about software deployment strategies. So we talked about testing strategies. Next Wednesday, we're going to be talking about software deployment strategies. Yeah. So, but rollbacks are important, and you know, in this case, Canary deployments are very useful because you don't have to release it all to see that you've made a mistake. But also, if you're not even doing Canary, if you're just doing your standard deployments, you can still keep on looking at things. Hey, does this work? Is this okay? Does this function? Is it fine? So, yeah.
Yeah, we also, at one of the places I used to work, we had a suite of testing, and it ties into the question from Prad Heepa about load testing. The reason that I'm combining with load testing is we used JMeter, which is an Apache project that you can use to run tests against APIs. It can do load testing for you as well, with interesting ramping up. I actually used it for our Let's Build episode that we did earlier this year. Sorry, last year. I don't even know if it was this year or last year. My brain just froze. But in case, what it is like, it's got the ability to also connect different steps to it. So the API that we were dealing with is we had a couple of test users in the system with actual data, but we knew that data wasn't changing over time. So what it would do is like it would first do a call to authenticate to the user, get the auth token back, and then do a whole bunch of subsequent calls saying, listen, get me this person's X information, that information. And there were some aggregates as well where the data was processed by a model and then stored, and then afterwards in that change shape, we could also do tests against that after every single time we deploy. We automated this. So it's actually a case of there was a bold step like once production deployment is completed and it's up, start running this JMeter test for us to make sure that it's working. The other load testing tool that I've seen, and I would love to use this purely because of the name, is, and I'm not joking here, is called Bees with Machine Guns.
I was want to mention that. Love it.
Yes. Yes. Basically, that spins up EC2 instances and uses those to actually do them. And another great use is using Lambda functions to actually do that. Because what you can do is you can set your Lambda function off to pull from a queue and actually use that to then start load testing from multiples. And what you can do is you can write something that very quickly fills up the queue with how many thousand or 100,000 or million of requests that you want. And then you can parallelize your Lambda and actually have like a bunch of these just start hammering your server. You just need to worry, obviously, about the concept called storming and herd, or in terms of your APIs. Like
herd.
Often APIs, when you herd 1,000 requests immediately, that storms your API and hurts it. It's like that thunking will hurt. So you want some kind of ramp up type, and I know JMeter is actually quite good with that, configuring and saying, listen, ramp up to 50 users with 50,000 requests each over the first 2 minutes. So there's a linear ramp up or logarithmic or however you want to configure it.
Yeah. I think also these types of testing are part of that integration, or that bigger, the second testing part where you have things deployed in a very similar systems, production-like systems. A load test on an alpha or beta system, doesn't give you a lot of information back. It just tests your alpha and load beta system. It might give you information if you're trying to get the metrics out to see how much the code is optimized. Yeah. But usually you should do that something that looks like production. Of course, you will not have a copy of production somewhere unless you can afford it. But as close as it can be to production, this is something you should use load tests for. Also, never load test in production unless you have a specific reason to do that. Because I had folks try to do that. I've worked with folks who are just like, hey, I will run JMeter or BlazeMeter against my production system, just to see how much it handled. Don't. It's going to cost you money. It's, plan for higher load, but test on something else. And you can't even imagine what happens if your higher load test breaks your production. So, yeah.
One more question here from Prat Heepa, which is around geospecific load you can simulate with JMeter. The good news is you can. And now here's a fun little hack for you to get this going in the probably the fastest way possible. Go use CodeBuild. Yeah, because CodeBuild effectively, you can provide your own container for it to run in, which means you can pre-configure JMeter inside the container and set everything up with how you want to test it. Then what you do is you use, because CodeBuild itself, you can set up a CodeBuild job with a container and say, go run that for me with very little setup. You do that with infrastructure as code. Terraform CDK CloudFormation, and then what you do is you decide which regions you want to deploy that in the world, and all of a sudden you've got the geo-distributed testing system. People tend to think of code build as just a service to build my code with, but effectively it is a mechanism to run a Docker container with very little scaffolding effectively. So it's probably the fastest way just to get a container up and running and do that. So that's what I've done in the past, actually. It didn't build anything. It literally just ran test.
Code build is the most universal testing tool out there. It's very closely approaching Lambdas to the way you can do that. But yes, code build. Most of your unit tests on AWS, you run code build. But in this case, you can have a JMeter thing to do that as well. So pretty cool.
Yeah.
So we're reaching up close to the 1 hour mark, and I have a really hard cutoff at 1 p.m. I have to deliver some training. So that has been discussion about software testing strategies, right, on AWS in the cloud, wherever. We have not focused purely here on some specific tooling or not. We just talk generally about those things. We like to continue talking about these type of topics, and we enjoy them. We have experience with them, and hey, it's DevOps, right? It's a box of DevOps. And next week we're going to be discussing something similar, but this time it's going to be deployment strategies, and also most importantly, the rollback strategies. Because you need to have a good deployment strategy is the one which has a rollback strategy. We're going to be talking about that next week at the same place at the same time. Actually, it's not the same time. It's next week. It's at 1
time is relative,
Central
Darko.
European time.
So we are heading into the fun week of the year. Remember, daylight savings changes kick in this coming weekend for those that do have daylight savings. I don't. Darko does. Yeah. So unfortunately, this will bring some disruption with it as well. So, for example, I know today we didn't update the official AWS Twitch schedule. Apologies for that. That was my mistake. I forgot to send off the request to have that changed. Yeah. But then from next week, we will be in the slot as indicated on the official AWS Twitch schedule. Before we do run, however, I'm not going to do the sponsor joke again because I don't want to have people run away again. But this video or this stream will be on our channel called Not Darko, Not Quibus. You can see it. Let me find
just
it
underneath
here. Underneath the beard over here. You can also see our different details there. I see we lost the Twitter icon. I'll need to go fix this little image of ours. But yeah, you can follow us on Twitter and also on our individual streams on Twitch. The reason we always promote this is that we want to make sure that people are aware of those and look at those, because we won't always be streaming on the AWS Twitch channel officially. So if you do enjoy these things, go subscribe there and you can get notified when we go live when it isn't on AWS, because sometimes there are events or there are other reasons why we can't stream here, but we still continue talking.
Yeah. And our sponsor,
and it's much more fun having people.
Yeah, and as Pedro masks here, so we don't forget to add the sponsor. Our sponsor today was coffee. Coffee made we will post the link to coffee. By the way, I think that's it. We can go back. Kobus, before we go, I want to show you something, and everybody else on stream. I'm a collector of useless technology or old technology or things that waste power for no apparent reason.
Yes,
I got something. It's a small TV screen. So it's a Sony PVM, or a professional video monitor. It's big, it's heavy, and it's only 9 inches. So it's a relatively small little TV, but excellent for that Super Nintendo out there. So I just need to find where to.
Well, you can use it for shoulder presses.
Yeah, exactly. It's not the lightest of things in the world. And I was just joking with my wife a couple of days ago. It was like, imagine if there was a world where mobile phones were not invented, and the way you go into bed and watch YouTube was like you have to bring a small TV, put it.
So here's a fun thing. If you go read the old sci-fi novels by Isaac Asimov, because they were written, I believe, in the 50s. So at that point, obviously, as a sci-fi writer, he was thinking about future ways of doing things. There was no concept of cell phones or mobile devices or anything. So the way he envisioned it was a method that a instant message comes to you as a piece of paper, I believe, where there's systems like tube systems inside the spacecraft or house or something, and out pops this message, if I remember correctly. And it's fun reading those old sci-fis where these things were not even thought about or spoken about yet. So the idea of how to solve that problem is super interesting.
Exactly. Or just play Fallout. Fallout is in a world where transistors have never been invented, so everything is vacuum tubes and triodes and all that stuff, triacs. So it is it is pretty fun. So
Yeah, Fallout. I am still trying to finish Fallout 4. I had logged 160 hours on it, and I canned that because there was a period where children were born where I didn't play at all, so I can't remember what I was doing, what my build was. So I've restarted. I've now managed to log about the same amount of time, and I've done one main quest. I'm just doing side quests and pimping out my character. I'm already on level, I think I'm 51 now or something.
wow.
So
That's good.
yeah,
That's good.
no, I love the
Cool.
just wandering and doing random things. But yeah, we are entering the end of today's session.
End of today.
Darko needs to run. He's getting
need to run.
nervous. I can talk for another hour. No, cheers, bye.
Thank you all. Thank you all for joining. Hope you liked it. Let us know on the social medias, on everywhere you can see here. Reach out to us if you have any suggestions, ideas for upcoming topics. Next week, deployment strategies, rollback strategies at the same place, at the same time. We will be seeing you here once again. Thank you all, and have a nice week. Bye-bye.
Cheers.